Thank you very much for the introduction, and thank you for giving me the opportunity to come to Bristol. Never been here, and I look forward to see a bit more of the city. And congratulations with the capital, European Green Capital this year. So I'll be talking about the status and also a little bit into the trends on air quality in Europe. I would like to acknowledge my colleagues from the European Topic Center on Air Pollution and Climate Change Mitigation and from the EA. I'll start with a very brief introduction on the effects of air pollution. Has already been extensively explained on the health impacts this morning. And then I'll give you some overview of an estimate of urban population exposure to levels above limit values and WHO guidelines in urban areas in Europe. And then I'll go through all the pollutants that are regulated in the air quality directives and where we stand in terms of exceedances, and also some of them in terms of trends and developments. And I'll finalize with a short summary. So as you know, air pollution is the #1 environmental risk for premature mortality in Europe. And I won't go more into the health effect part since it has already been so well covered earlier. But air pollution also has quite some impacts on ecosystems in the environment, both in terms of leading to acidification and eutrophication. And we've been listening about these issues for decades, but they are still not solved, and they are not expected to be solved in the next decades either. Sometimes because the critical levels have been so exceeded over such a long time that it will take decades for the ecosystems to recover, even though we reduce considerably the emissions these days. Some of them not, like ammonia hasn't been considerably reduced, but SO2 has. Ozone is still causing a lot of damage on vegetation, including crops and forests in Europe, especially in the south. And we also have some air pollutants that are also climate forces, the so-called short-lived climate forces like ozone and black carbon. And some of them are leading to the formation of these climate forces. PM is also impacting indirectly on climate through changes in cloud formation, rain patterns, and so on. This table gives you an estimate over the percentage of urban European population exposed to levels above the European target or limit values on the left and the WHO air quality guidelines on the right. And as you can see, and also already mentioned this earlier this morning, sometimes the limit values do not in any way correspond to the WHO guideline levels for protection of human health. And you can see that even though exceedances may look like relatively limited, the health effects may be quite considerable. For example, for PM2.5, over 90% of the European urban population is exposed to levels above the WHO guideline, while looking at the target value, which is much more relaxed, 25 micrograms per cubic meter as an annual mean, then you only have 10 to 14% of the population. One comment on the NO2 that doesn't look so bad here, and is probably underestimated because this is mostly based on urban and suburban background stations. And as you know, NO2 is more of a hotspot issue close to traffic, even though already showed earlier this morning in London, this may also be rather important also in the background of the city. Our estimates show between 8 and 13% of the European urban population exposed to levels above the 40 micrograms per cubic meter as annual mean, probably underestimated, as I said. And these estimates are based on the data from 2010 to 2012 to give some variability of meteorological variability from year to year, so the concentrations change. SO2, carbon monoxide, lead, and benzene look like less of a problem in terms of, at least in terms of exceedance of limit values, but for some of them the WHO guideline also shows that we have some work to do especially in certain areas in Europe, and I'll get further into this later. I should say also that all this data is based on the last air quality in Europe report from the EA, which was for 2014. This year's report will only be released in November, so the data, the latest data I can show is for 2012 here. Okay, this is a map of the PM10 concentrations and exceedances of the daily limit value across Europe, and as you can see, the limit value is broadly exceeded more or less all over, especially in the Po Valley, southeastern and central Europe, but also in urban areas in Scandinavia. So this is a widespread problem in Europe. And if you look at attainment, you can see that 21 EU member states have exceeded this limit value. I show this limit value because it's more stringent than the annual mean. But here the UK doesn't show as any exceedance, at least not in 2012. But 21 member states were exceeding this limit value, so PM10 is still a major issue in Europe. In terms of PM2.5, and again here we have a really big difference between the WHO guideline 10 micrograms per cubic meter as an annual mean against the target value, the EU target value, which is 25 micrograms per cubic meter. So in terms of exceedances, we see them mostly in Poland, Po Valley, and the Balkan countries. But if you look at the stations with concentrations under 10 micrograms, which is WHO guideline, then you only have a few freaks, especially up in Scandinavia, and there are also exceedances across the continent. Regarding the target value, it's 8 member states with real big problems in terms of PM2.5, and the others are not in exceedance, including UK here. Okay, now we get to the trends and how are things improving or not improving. In terms of PM, we see improvements especially in traffic and industrial stations here represented as other, with an average reduction of both PM2.5 and PM10 concentrations in the last decade, but very slowly improving, as you can see. Urban and rural background stations are not decreasing so fast. They also have lower concentrations as a starting point. But for PM2.5, actually, we see that the levels of PM2.5 are not decreasing in urban areas, at least not in the average over Europe, in the background and in rural areas, indicating there's maybe some sources that are contributing to maintaining these levels, despite the fact that there has been some efforts, technological measures, especially on traffic and industry, to reduce primary PM2.5 emissions. And we believe it's very much due to an increase in emissions from the domestic combustion sector, and also a maintain in emissions, ammonia emissions from agriculture, that have been little reduced and that contribute considerably to the formation of secondary inorganic aerosols. In terms of ozone, as you know, we have a south-north gradient, so the major problem is in the southern Europe areas. And here I show exceedances of the limit value for the protection of human health, which is widely exceeded in the south. A little bit of the same picture in terms of exposure or exceedance of the limit value for the protection of crops in Europe. It's the red parts are in exceedance, but all the yellow parts are in exceedance of the long-term objective for protection of crops from ozone exposure. And in Scandinavia, the yellow parts are very much due to the high altitudes. For forest, it's even more stringent, the critical level set by the convention. So actually the whole yellow area is above the critical level. Also the integration period for the AOT 40 for the protection of forest is longer, is 6 months instead of 3 as for crops. So there is wide exceedance of this critical level for the protection of forests in Europe. And back to the limit value for the protection of human health, there is 19 member states of the EU are in exceedance of this limit value, so ozone is a major issue across Europe and also a very difficult one to solve since it's a continental dimension issue, and actually input of ozone into Europe has increased, compensating a little bit for the decrease maybe due to decrease of emissions within Europe. So there's a lot of issues here that haven't really been understood and trying to deal with. It's a difficult issue and it has to be dealt on a regional and international level. This trend analysis for ozone is only based on 10 years, and as you know, ozone changes a lot from year to year due to the meteorological differences from year to year. So we've seen there's not so many significant, not so many stations with significant trends on ozone, and this is just an averaged change or trend per station type indicated here. But we see some decrease in urban and rural background, and to a lesser extent in the traffic and industrial stations, and we believe this is very much due to the fact that NO and NOx emissions have been reduced, so you have less ozone consumed to oxidize NO into NO2, and therefore you see less. Also there are the levels in traffic stations are lower, so you see a lower reduction there. In terms of NO2, and already mentioned earlier, the problem is widespread and it's very much everywhere. More or less all member states have once in a while problems with exceedance of the NO2 limit value, which is the same as the WHO guideline, and which again already showed earlier this morning doesn't necessarily mean the population is protected. But we see large exceedances more or less everywhere in urban areas, including Scandinavia and very much over the UK. Seems traffic is a major issue in the UK, more maybe than some of the other medieval indicators as mentioned this morning. It's mass-based PM is not so obvious to see whether or not the population is protected. And also, as you see, in terms of exceedances, it's 20 member states have problems with attainment of this limit value. Actually, the UK has registered in 2012 the highest annual average of all stations measuring in Europe. Most of the stations for NO2 with exceedance are traffic stations. So, and it does decrease relatively fast from close to the source into more background. So this is a problem of exposure close to traffic, and so traffic must be dealt with. In terms of trends, here too we see relatively low decrease in concentrations. Was already mentioned earlier. One of the issues is that there has actually been in many countries an increase of diesel vehicles, and diesel vehicles at the same time have not met the expected decrease in NO2 emissions. So the decrease has been much slower than expected and hoped for, and that's also why we still have these large exceedances across Europe that were expected to be, to a much large extent, solved by now. yeah, reductions are mostly seen in traffic stations as expected, where concentrations are also higher. And as you also see, there's many stations that actually have shown an increase, not a decrease. I think in some cases there has been a pro-diesel policy, which has also led to this situation. Benzoypyran is actually, in my opinion, often an almost forgotten issue. I think Poland is very much aware of it, but many other countries do not realize this is a major problem over large areas of Europe. There's large exceedances of this target value of 1 nanogram per cubic meter. And actually, if you look at the WHO acceptable risk of 1 cancer incidence in 100,000 inhabitants, you would have a safe level of 0.12 nanograms per cubic meter, which is here given by the dark green dots. So there are quite high concentrations. They are very much associated with domestic combustion. And looking at the development in emissions of BAP, we see an increase in the last decade in the EU. Domestic combustion accounts for 85% of the total emissions reported in the EU. So it's the main cause, even though industry in some areas is also, and traffic to a certain extent. This is the main sector that needs to be dealt with. And this emission sector has also increased its emissions considerably, both of benzoypyran and other PAHs. Obviously, this is the indicator for PAHs, but also of PM2.5, as I mentioned earlier, and we believe that's also one of the reasons why PM2.5 has not decreased in average in Europe, because these emissions have actually increased due very much to still combustion of coal, especially in Central and Eastern Europe, but also in some countries an increase in consumption of wood due to higher electricity prices and the crisis, but also due to, in my opinion, misunderstood climate change mitigation policies that have promoted the use of wood for domestic heating, and that is driving also this development. So in terms of exceedance of the target value for BAP, there are 12 member states that are in exceedance, and this is, in my opinion, a rather high target value. As I said, the WHO, or it's not WHO, but the calculated reference level would be down to 0.12, so almost 1/10 of these levels. And there are also quite some countries that are probably in exceedance of the target value, but do not measure. So, for example, Romania, we expect to have very high concentrations there, and there are no measurements. SO2, it doesn't seem to be much of a problem in terms of impacts on health and exceedance of the limit value for protection of human health. It's very punctual and quite rare these days. It's more of a problem in terms of deposition and contribution to acidification, which is an issue that has not been solved in many areas in Europe, especially Scandinavia, where ecosystem is very sensitive to acidification. Here I show the compliance with the limit value for the protection of vegetation, but it's in terms of concentrations, not deposition, and here also we see very seldom exceedances across Europe and very punctual. Benzene is still exceeded in many countries across Europe, but it's also a relatively local issue and problem close to some sources and not a widespread issue, even though you see some red dots across many countries, and also the lack of more measurement stations is not so widely measured in Europe. In terms of metals and looking at the limit and target values, The exceedances are also relatively few and quite localized, very much associated to industrial emissions. So they are and should be dealt with locally. But the problem with metals is it's more the fact that they deposit into the ecosystems, and they do accumulate in the food chain, so they will impact on human health via food, not so much via the air we inhale. In terms of exceedance of the critical loads for deposition of metals, cadmium is a lesser problem. Most countries have exceedance of the critical level in less than 1% of their ecosystem area. Lead is still a problem in quite some countries. Atmospheric deposition of lead exceeds the critical loads in over 12% of the EU ecosystem area. But mercurium, which is not regulated in terms of air concentrations, but it's regulated in terms of emissions, is still a major problem. More than half of the EEA 33 countries have exceedance of their critical loads for mercurium across 90% or more of their ecosystem area. And in total, in the whole EU ecosystem area, there is 54% of the area that is in exceedance of mercurium critical load. So this is definitely still a very important problem. In terms of reduction of emissions, in general, they have been decreasing, some more like SO2, and some less like ammonia, which is more than 90% emitted from agriculture, and also is still maintaining levels of background PM2.5 in Europe. In terms of metals, they've also decreased. Again, some less and some more like nickel, but benzoapyrene emissions have increased, as I mentioned, and must definitely be looked into more closely. I should also mention that this data is based on officially reported emission data, and unfortunately, PAH emissions are not, it's not compulsory to report them, so BAP emissions are only reported by 20 countries of the 28, and there are quite some uncertainties related to these emissions. So, as a summary, we see that almost 1/3 of Europe's city dwellers are exposed to excessive concentrations of PM levels, and emissions have declined in general over Europe, resulting in some improvement of air quality, but not as much as we had planned and hoped for in the last year, so we definitely need to do more. Most countries are still not complying with one or more limit and target values in the EU, and some limit values are extensively exceeded, like the daily PM10 limit value, NO2 and ozone. And road transport, households, power plants, industrial activities, and agriculture continue to emit considerable amounts of air pollutants, which are responsible for exceedances of these limit values. And several air pollutants continue to lead to considerable impacts on ecosystems, forests, and crops, in addition to human health, as I mentioned. So, thank you very much.
Srinivas Rimas from RSK. We compare several states, and as I understand, there are differences in the types of sites, monitoring sites, and how, when we are comparing, how those are addressed. That's what I wonder.
I'm sorry, how we relate to the different types of sites?
Yeah, monitoring sites. That are, for example, in the UK, we have curb sites and roadside sites.
Yes.
And as I understand, you have shown this traffic as one of the types of the sites. And while comparing, how you have addressed that issue?
Well, we do account. I showed you a very simplistic analysis of the data. In the report, it's much more detailed. We do account for the representativity of the sites and the different classifications. I showed you for the trends, we calculate depending on the types of sites. In the maps, I didn't show it here so much because it becomes a bit of a mess to distinguish the different classifications. We tried that in a first map, but it wasn't so useful. But yes, we look into the different types of sites. We look at the exceedances. For example, NO2 exceedances occur in more than 90% of the exceedances occur in traffic sites, but you also have quite some urban or suburban background sites with exceedance levels. So yeah.
I think the question might also have been, is the roadside site in, say, Germany the same as in the UK?
Oh yeah, well, not necessarily. I mean, the directive does attempt to clarify the siting requirements and the representativity requirements. When we looked at the actual positioning of the stations, what they represent, it varies quite a lot, and it varies, yeah, sometimes within the country too, because very often municipalities are in charge of the monitoring, and they may interpret things differently, or yeah, they have different systems. So yes, last year we did some study to look at where sites are positioned. We found rural background sites within urban areas. So yeah, there's lots of misclassifications there too. You're welcome.
Anyone else in the audience? Okay, in which case I'll say, when you look across Europe and you look at all these data you collect and you see the trends, are you an optimist or a pessimist for the future?
Cautious optimist. I think actually the known pollutants, I think we are tackling them. I also think that within the next years, and also very much driven by the climate mitigation policies, we may have quite some improvements in urban areas due to more district heating systems and less polluting transport systems. But I see all the time new pollutants emerging that we didn't know of, that turn up to be new problems. So, and the legislation is very slow relating to exactly these new pollutants and new toxics. So I'm also apprehensive to that development, especially the unknown part of the problem.
Okay.